Hi, I'm here to tell you a basic understanding of a power of a point theorem. So before we begin, there are three geometric terms we should know. Chord is a straight line segment which have a endpoints on a circular arc. So it has two endpoints on a given circle. And secant is a straight line segment that cuts a circle in two or more parts. So it has no endpoints as like a chord. And tangent is a straight line that touches the circle at only one point, like here. So let's begin. So the first one is a chord-chord power theorem. So when you see the two chords in a given circle, then you should think of this power theorem. So the conclusion of this theorem is this: A multiply B equals to C multiply D. So when you see the two chords and the intersecting points, you should think of the four divided segments. And think of this as an X shape, like this, X shape or ribbon. And A multiply B will equal to C multiply D, and I'll show you why. So this is the proof. So when we draw a line, this blue line, we can make this two triangle. And by the inscribed angle theorem and vertical angle theorem, we can know that there are three common angles that have the same value with each other. And we learned that if the two triangles have two same angles, we call these triangles similar. And so triangle AEB will be similar to triangle DEC. And if the two triangles are similar, we can make a formula with the corresponding parts of the triangles. And based on this formula, we can know and figure out that AE multiply EC will be equal to DE multiply EB, which is the formula of a chord-chord power theorem. So just remember this X shape. So let's solve this problem. So we see the two chords intersecting in a point in a given circle. So we can now use the formula 7 multiply 4 equals to 6 multiply x. And then x will be 14 divided by 3. So let's move on. The second one is a secant-secant power theorem. So this is just a basic formula with two secants intersecting at a given point P. So this is the easiest way to remember. So A multiply B equals to C multiply D. So based on these intersecting points of a two secants, we can figure out the four segments between the two segments and the circle. So when you find the four segments by the endpoints, you should figure it out. A multiply B equals to C multiply D, the shorter one and the longer one. So think of the triangle-shaped hat when you think of the secant-secant power theorem. So this is the proof. So same as the chord-chord power theorem, we should draw a line and make two similar triangles. So based on the reflective property, these triangles have same common angle A, and angle BED will be same as angle C by the alternate opposite angle in a quadrilateral. And because the triangles have two same angles, these two triangles will be similar by AA similarity. And now we can come up with this formula with using the corresponding parts of the similar triangles, and we can now figure it out that AB multiply AC will be equal to AE multiply AD, which is the formula of the secant-secant power theorem. So let's solve this problem. So we can now know that there are two secants in a given circle, and we should figure out the triangle-shaped hat. So 2 multiply 12 will be equal to x multiply x plus 5, and then the x will be 3. So the last one is secant and tangent power theorem. So this theorem, we can just find one secant and one tangent in a given circle. And the formula of the secant-tangent theorem is that A, the longer one, multiply B will be equal to C squared. So when you think of this theorem, we should find out this one point that this tangent line makes the circle. So think of the alligator mouth when you think of this theorem. So c squared will be equal to b multiply a. And this is the proof. So when we also draw a same blue line here, we can find out these two triangles, ADC and CBD. And because we also know that by the reflective property, these two triangles have the same angle A, and by the alternate secant theorem, angle C is equal to angle ADB. And we can now know that these two triangles are similar by AA similarity. And based on the corresponding parts of the similar triangles, we can figure out that AD squared will be equal to AB multiply AC. So let's find out this problem. Solve for x. This is the secant-tangent theorem, and x squared will be equal to 9 multiply 25. So the answer x will be 15. So this is the summary